Hello students, this is RANJEET SHAHI, and in this video we are going to discuss about the IIT-JEE 2015 mains paper. We are going to solve the IIT-JEE 2015 mains paper chemistry. We will be taking one by one the question very thoroughly. We will be solving the entire paper of IIT-JEE 2015 mains in two parts. In first part we will be solving first 15 questions, and in second part we will be solving second half of the paper. So I think this will help you a lot because I am going to give you a very detailed video solution, but very simple and straightforward solution so that anyone can understand. As we all know, in JEE mains the questions asked are very simple, very straightforward, but instead of all these things, usually there remains 5 or 6 questions of good quality, and the same was true in IIT-JEE 2015 also. In JEE 2015 mains there were a couple of good questions in chemistry. At least 5 or 6 questions were of very good quality, and their solutions are crucial. So with the solutions of those questions, I am going to inform you also a lot about the concepts behind those questions. So I have the paper of IIT-JEE 2015 mains offline paper. So the paper in my hand is JEE mains 2015 offline, that is pen and paper exam, and the question I have is set B. So I'm a chemistry instructor, so I'm going to solve the chemistry part only, and you will see a lot of difference in this solution and the solutions provided by some of the great teachers of the so-called Great Institute of India. So let us start with question number 1. The first question is related to atomic structure, description of Bohr's atomic model. The question is, which of the following is the energy of a possible excited state of hydrogen? Which of the following is the energy of a possible excited state of hydrogen? As we all know that the energy of a stationary orbit, energy of a stationary Bohr orbit for hydrogenic atom is given by the expression E is equal to minus kz square upon n square. And for hydrogenic system, K is 13.6 electron volt, Z is 1 for hydrogen. So this E for hydrogen atom can now be written with this constant as minus 13.6 upon n square electron volt. The question is, I am repeating, which of the following is the energy of a possible excited state of hydrogen atom? So for excited state, n must be greater than 1. So n could be 2, 3, 4, whatever it is. N cannot be 1. The options given in the questions are, the option 1 is minus 6.8 electron volt. Option 2 is minus 3.4 electron volt. Option 3 is plus 6.8 electron volt, and option 4 is plus 13.6 electron volt. So this 4 and 3 option 4 and 3 are clearly ruled out, since they are positive and energy of a stationary orbit will never be positive, since the value of n is always positive, so this will always be negative due to this minus 1. So these two are not possible. Then between these two we will have to check for the values of 2, 3, 4 one by one. So if we put n is equal to 2, E2 will become minus 13.6 upon 4, and it is 4, 3 that 12, 1, 4 electron volt, and this is the second. So the answer is 2. So this was a pretty good but simple question, and just by sincere calculation this question could have been done very easily. So let us move to question number 2. Second question is from organic chemistry, and that question is related to predicting a product of a reaction. The question requires to answer the product in the final step of this reaction. Here it is given, question number 2. We are solving set B. So the question is, toluene KMnO4 gives A, SOCl2 gives B, and then H2PD BaSO4 gives C, and the question is, what is C? We all know toluene is methyl benzene, and we learned that if an alkyl benzene containing at least one alpha hydrogen, means it could be methyl, ethyl, propyl, butyl, whatever, there must be at least one alpha hydrogen. When treated with KMnO4, there should have been some base also. The medium must be specified, but it's a JEE mains question set by CBSE, and we can take something granted for that. So toluene KMnO4, since acid medium is not given, so we cannot expect the rupture of benzene ring, so we'll assume that it is alkaline. So here in all cases the alpha carbon is converted into COOH. So benzene with one COOH, this is a general reaction of alkyl benzene, any alkyl group containing alpha hydrogen on benzene when treated with potassium permanganate in slightly alkaline medium, it is oxidized to KMnO4. The second step is reaction of acid with SOCl2, so obviously acid chloride will be formed, and the last step is like Rosenmund reaction. So in the last step, a reduction will occur, but controlled reduction giving benzaldehyde. So the final product here is, benzaldehyde, and the answer is 3 in the option. The third option is benzaldehyde, so the answer will be benzaldehyde. So let us move to third question. Question number 3 again from organic chemistry, and the question is, which compound would give 5-keto 2-methyl hexanyl upon ozonolysis? The question is, there is a compound which on ozonolysis followed by zinc hydrolysis giving 5-keto 2-methyl hexanyl, and the options are, the first is this one, the second is this, the third is this, and the fourth is this. As we all know, in reductive ozonolysis, what happens, that carbon-carbon double bond is cleaved. In reductive ozonolysis followed by zinc hydrolysis, the CC bond is broken, giving carbonyl on both sides. Then they can both be ketone, they can both be aldehyde, one can be ketone, one can be aldehyde, depending upon the groups present on the 2 carbon. So for aldehyde, there must be at least 1 hydrogen and 1 alkyl group, and for ketone, both must be R. The compound 5-keto 2-methyl hexanyl, 5-keto 2-methyl hexanyl, 1, 2, 3, 4, 5, 6. So it is hexanyl. 1, 2, 3, 4, 5, 6. 5-keto 2-methyl. This is the compound we are looking for. It's an aldehyde. This will give ketone on both ends. So this is ruled out first. Then, if we can highlight the hydrogen at double bond, we have hydrogen here. And the carbon at which we have hydrogen gets converted into aldehyde. So, here we will have this part aldehyde, CHO, and the carbon of aldehyde will be numbered 1, so 1, 2, 2-methyl, 3, 4, 5, this will be ketone part. So 1, 2, 3, 4, 5, 2-methyl, 5-keto hexanyl. So answer will be this. What is wrong in other? Here this carbon will become aldehyde, so 1, 2, 3, so it will become 3-methyl, so we require 2-methyl, so it is not the answer. Here also 1, 2, 3, 4, so it will be 4-methyl. So this will not be the answer. So it's a very simple question. There is nothing difficult in this. So let us move to next question, question number 4. In question number 4, the question is, we can say periodic property. The ionic radii of N3 minus, this is question number 4. The question is, ionic radii of N3 minus, O2 minus and F minus. We have to make prediction about the radius of these three, and these three, let me write the option also. The options are 1.36, 1.36, 1.71, 1.40, 1.71, 1.40, 1.36. Third is 1.71, 1.36, 1.4. Fourth is 1.36, 1.40 and 1.71. So in respective sense we have to predict the radius. If we can see, they are all isoelectronic. They are all isoelectronic species. N3 minus, O2 minus, F minus, they all have 7 plus 3, 8 plus 2, 9 plus 1. So they are all 10 electron system. They are all from the same period. And as we know that in the same period, if the species are isoelectronic, then more the negative charge, larger the size. So it has the largest size, then this, and then the smallest one. It will be largest and the other one will be smallest. Radii in angstrom units are given. So the largest value is 1.71 and the smallest is 1.36. So 1.71 largest, 1.36 smallest, in between 1.4, so the answer is 2. So this is regarding ionic radii, and we all know that ionic radii depends on effective nuclear charge first, if they are from the same period, and effective nuclear charge will be lowest in case of N3, since the NYP ratio or the proton to electron ratio will be smallest for this and it will be largest for this. So proton to electron ratio will be largest for this. So largest effective nuclear charge, smallest size, smallest effective nuclear charge, largest size. Right? So now move to question number 5. Question number 5 is related to the color. The question is, color of KMnO4 is due to what? As we all know that potassium permanganate, when we dissolve in water, gives a dark purple color solution. Color of my shirt is also dark purple color. So potassium permanganate gives a dark purple color solution. So what is the reason for the color? Potassium permanganate is a transition metal compound, and we have learned in coordination compound that color of complexes arises from the DD transition which occur in the visible region of electromagnetic spectrum, in which electrons from low energy d orbital gets transferred to high energy d orbital. But now here we have very different situation. Manganese is in +7 oxidation state, and for manganese we have 3d5 4s2. So total 7 valence electron with manganese +7, we have 3d0, no valence electron. So no DD transition. Okay. But we must be very careful that DD transition is one of the criteria for the color of complexes, but not the only criteria. There are several other criteria of color. So let me explain you this question in little more detail. What we have here, MnO4 minus ion. Besides DD transition, there are some other transitions which also occur in the visible range of electromagnetic spectrum, and they are called LMCT, ligand to metal charge transfer, and other one is MLCT, metal to ligand charge transfer. So ligand to metal charge transfer and metal to ligand charge transfer also occur in the visible region of electromagnetic spectrum, and they also impart color to the substance. What is LMCT? Ligand to metal charge transfer. This occurs when metal is in high oxidation state, that is, has no electrons or very few electrons. Very few electrons. And ligands have lone pair of electrons. So here in this case we have manganese +7 vacant and oxygen with lone pair of electron. So what happens here? Ligand to metal charge transfer. Ligand to metal charge transfer occur, and this occur in the visible region, giving color to potassium permanganate. But we must know that D0 is not essential. We know that magnetine MnO4 2- is also green colored, and that is again due to the same reason, LMCT. But here manganese is not 0. Here manganese has an electron. Similarly, CrO4 2-, Cr2O7 2-, VO4 2-, they are all colored due to LMCT, ligand to metal charge transfer spectroscopy. So the color of this is due to this LMCT, ligand to metal charge transfer spectroscopy. I have written one more, so just in 1 second I will explain you this second part also. What is MLCT? So this question is already answered, that the color of potassium permanganate is due to ligand to metal charge transfer, but just in a second I am explaining you what is the another type of transition that may be asked sometime later. So metal to ligand charge transfer, MLCT, this occurs when metal is in low oxidation state. In the previous one, metal must be in high oxidation state. Here the metal is in low oxidation state and possess electrons in d orbital that can be transferred, to the vacant pi star molecular orbital of ligands, usually organic ligands. Ligands like you can see ligands of this type, although it is a bit of higher standard in your level, but that KMNO4 question was also not of your standard, but if that is asked, this can also be asked. So it is 2,2 dipyridine. Similarly, we have another ligands falling in this category. This is 110 phenanthroline. They are the ligands which have vacant pi star molecular orbital, and so the electronic transition from metal to ligand takes place. So metal to ligand charge transfer spectroscopy, and that falls in the visible region, giving color to the compound. So let us move to next question, question number 6. Next we move to question number 6. So the question number 6, is an assertion region type of questions, and in this question sorry, The assertion is nitrogen and oxygen are the main components in the atmosphere, but these do not react to form oxide of nitrogen. This question is related to air, our atmosphere, and we all know that in our atmosphere nitrogen and oxygen are the main component and they don't react. That is true also, they don't react. That is a statement which is a correct statement. The reaction between nitrogen and oxygen require high temperature. That is also true. So this reaction between nitrogen and oxygen to form nitric oxide has very high activation energy. It has very high activation energy. So under normal condition the reaction occur at negligibly slow rate. So in order to become the significant rate, in order to obtain the significant rate of reaction, the temperature required would be very high. And this reaction, we have learned a bit about this reaction in inorganic chemistry also, that this reaction occur at a temperature above 2000 degrees Celsius, that is during the lightning only. So the region given is the reaction between nitrogen and oxygen require high temperature. That is also true, and that is the reason why they don't react. So both a statement and a reason are correct, and the reason is correct explanation of assertion also. So its answer will be fourth answer. Answer 4. Both assertion and reason are correct, and reason is correct explanation of assertion. So this is a simple question. Here I continue the question number 7, that is also very simple and theoretical question. Which of the following compounds is not an antacid? Which of the following compound is not an antacid? This is related to molecules of life chapter of your NCERT book, in which there are descriptions of antacids, antidepressant and all. So the options are, option 1 is cimetidine. Option 1 is cimetidine. Option 2 is phenylizine. Phenylzine. 3 is the very common one, ranitidine. And the 4 is aluminum hydroxide. The question is which is not an antacid. Antacid reduces acidity, neutralizes acid, so they must be basic. So it is antacid. These two are also basic, they are also antacid. This one is antidepressant. It's not an antacid. This is antidepressant. This is taken when a person goes into depression. So this is a theoretical question. Then question number 8. Let us move to question number 8. So question number 8 is again a question from inorganic chemistry. In question number 8, the question is related to extraction of aluminium by Hall-Heroult process. The question is, in the context of the Hall-Heroult process for the extraction of aluminium, which of the following statements is false? Which of the following statement is false? Means Hall-Heroult process जिससे aluminium का extraction होता है, उसके बारे में कौन सा statement wrong है? Which of the following statement is wrong? The first statement is Al2O3, aluminium oxide is mixed. Al2O3 is mixed with calcium fluoride, which lowers the melting point of the mixture and brings conductivity. That is correct. Al2O3 is mixed with calcium fluoride. Also, cryolite Na3Al(F6) is mixed, and these two lowers melting point of alumina and improve electrical conductivity so that it can be electrolyzed. So it is correct. Second is Al3 is reduced at cathode. We'll be talking about this just after a while. Third is Na3Al(F6) serves as the electrolyte. Na3Al(F6) serves as electrolyte, and the fourth is CO and CO2 are produced in this process. CO and CO2 are produced. The question is which is wrong. We have already discussed that this is the correct statement. CaF2 is added to lower the melting point and to improve the electrical conductivity, correct. Cryolite alumina is also added, but calcium fluoride is also added. So that is correct statement. During the extraction by electrolytic method, oxygen gas is produced at anode, and since electrolysis occurs at very high temperature, so some of the oxygen reacts with carbon of the anode. Graphite anode is used here, carbon of the anode, forming both CO and CO2, so this is also correct. Now what about these two? Most of the solutions available on internet tells that this is the wrong statement. Na3Al(F6) serves as electrolyte. I have seen an official solution of JEE mains also, and they also say that this is the electrolyte. So सरकारी आंसर है तो मानना ही पड़ेगा. This serves as an electrolyte. But let me tell you the fact, what is correct. If everyone is saying that this is the electrolyte, and if it is not correct, then the wrong answers given by mass will not become the correct answer. All good books of inorganic chemistry clearly writes that there is no evidence of Al3+, there is no evidence of Al3+ and Al3 plus is not reduced. So Al3 plus is reduced at cathode is actually wrong, and this should have been the answer. Actually, it is not the Al3 plus. It is the reduction which occur at cathode is AlF6 3 minus plus 3 electron giving aluminium plus 6F minus, or AlF4 minus plus 3 electron giving Al plus 4F minus. They are the reactions which occur at cathode. And in electrochemistry, we know that we cannot say the reduction of this and the reduction of aluminium 3 plus are same. They are different electrochemical process. They are different electrode reaction. So according to me and according to the world, this would have been the answer, that this is reduced at cathode is a wrong statement, but JEE Mains official site gives this answer. And most of the great teacher who provide solutions of JEE Mains follow the same trend, that they are also saying that this is the answer. But according to me, I am not convinced with that, but I am saying that this is the answer given by most of the solutions, given in most of the solutions. But according to me, this should have been the answer. This is the wrong one. This is the right one. This acts as an electrolyte. If this is being reduced, then this must be acting as an electrolyte. That is a correct statement. That cannot be a wrong statement. So move forward. Leave it now. So let us move to the next question. That is question number 9. In question number 9, question number 9, question number 9 related to match the catalyst. That is very simple, and that is memory based question, so just I am writing the answer. So TiCl3, this we do in polymer. This is used for stereochemical control in the polymerization reaction. This is Ziegler-Natta catalyst. Ziegler-Natta catalyst. So this is A, and this is the third on the right side of the column. Then palladium chloride PdCl2 is the second one. This we all know, we use in Walker process. Which is first on the right column. CuCl2, this also we all know in Deccan process, which is the fourth on the right side, and V2O5, we all know this is the well-known catalyst, vanadium pentoxide, we use in contact process. So A3, B1, C4 and D5. A3. So the answer is third one. A3, B1, C4. Sorry, no. Answer is fourth one. A3, B1, C. वो 5 कहाँ से आ गया? C4 and D2. D, oh something wrong is there. It is Ziegler-Natta catalyst, it is the second one. So Walker process, palladium chloride, CuCl2, Dacon process, C4, correct. And D, vanadium pentaoxide, contact with third one. 5 तो ऑप्शन ही नहीं है, थर्ड वन. So A2B1, C4, D3. So the answer is first one. Next, question number 10. Question number 10 is again a simple organic reaction. In question number 10, the question is related to predicting product of a reaction. The reaction is related to diazotization reaction, NH2CH3. The first is NaNO2 HCl, 0 degrees Celsius. It's a diazotization reaction. D is the product level here. Then CuCN, KCN, heat, E plus N2. So obviously this is N2 plus Cl minus diazonium salt, and this is Sandmeyer type of reaction. So CuCN, KCN will convert this to cyanide, giving N2 gas and CuCl. So the answer is second. So this is again very simple. Now move to question number 11. Which polymer is used in the manufacture of paints and lacquers? Which polymer is used in the manufacture of paints and lacquers? पेंट और लिकर्स बनाने के, लैकर्स बनाने, लैकर्स का मतलब होता है एडहेसिव एंड ऑल. पेंट एडहेसिव बनाने के लिए कौन सा पॉलीमर यूज होता है? ऑप्शन है, फर्स्ट ऑप्शन है एक पॉलीमर जिसको कहते हैं ग्लिप्टल. दूसरा है पॉलीप्रोपिलीन. तीसरा है पीवीसी, पॉलीविनाइल क्लोराइड. और फोर्थ है बेकेलाइट. पेंट्स लैकर्स बनाने में कौन सा पॉलीमर यूज होता है, यह है क्वेश्चन आपका. तो पेंट में पॉलीप्रोपिलीन कहीं नहीं यूज होता है. पॉलीप्रोपिलीन एक कॉमन प्लास्टिक है जो कि कैरी बैग जिसका बनता है. ढेर सारे घर में हाउस होल्ड अप्लायंसेज जो होते हैं वो पॉलीप्रोपिलीन के बने होते हैं, पॉलीथीन जैसा ही होता है. पीवीसी भी पेंट में नहीं डलता, ये भी हमें मालूम है, क्योंकि पीवीसी के घर में मग्गा, बाल्टी, इलेक्ट्रिकल वायर का इंसुलेशन, ये सब पीवीसी का बना होता है. बेकेलाइट भी नहीं पेंट में यूज होता है, क्योंकि बेकेलाइट हम पढ़ते हैं फिनॉल के एक रिएक्शन में. फिनॉल को फॉर्मल्डिहाइड के साथ एसिडिक बेसिक मीडियम में ट्रीट करके जब आगे हीट करते हैं तो नोवालोक बन के आगे वो फिनॉल फॉर्मल्डिहाइड का एक क्रॉस लिंक पॉलीमर बनाता है जिसको बेकेलाइट कहते हैं. और उस बेकेलाइट की प्रॉपर्टी होती है थर्मोसेट होता वो, यानी कि एक बार सेट हो गया तो वो हीट करने पे डिफॉर्म नहीं होता. इलेक्ट्रिकल स्विचेज एंड ऑल बनते हैं. तो ये भी नहीं, तो बच गया ग्लिप्टर. तो ऑडमैन आउट करके तो इसका आंसर ऐसे निकल गया. बट नॉलेज के लिए हम जान लेते हैं कि ग्लिप्टल होता क्या है थोड़ा सा. तो ग्लिप्टल बेसिकली कॉमर्शियल नेम है एक खास तरह के रेसिन का, जिसको अल्काइड रेसिन कहा जाता है. और ये रेसिन क्या होता है, तो ये बेसिकली पॉलिएस्टर होता है. पॉलिएस्टर्स जो कि यूजुअली ग्लिसरॉल और थैलिक एनहाइड्राइड, ग्लिसरॉल और थैलिक एनहाइड्राइड के कंडेंसेशन पॉलीमराइजेशन से बनता है और ये यूज होता है, रेसिन है, ये यूज होता है पेंट इंडस्ट्री में और एडहेसिव बनाने में। तो क्वेश्चन नंबर 11 ये था। नेक्स्ट इज क्वेश्चन नंबर 12, कोऑर्डिनेशन कंपाउंड का क्वेश्चन है। इस क्वेश्चन में पूछा जा रहा है कि द नंबर ऑफ ज्योमेट्रिक आइसोमर्स दैट कैन एग्जिस्ट फॉर स्क्वायर प्लेनर, the number of geometric isomers that can exist for square planar PTCl-Y NH3 NH2OH PTCl PY NH3 NH2OH NH2OH और इस पे प्लस चार्ज लगा हुआ है और क्वेश्चन में ही दे दिया गया है कि ये स्क्वायर प्लेनर कॉम्प्लेक्स है। तो प्लैटिनम सेंट्रल मेटल हो गया और इससे 4 डिफरेंट टाइप ऑफ लिगेंड्स, सिंपल समझने के लिए इसको हम ए बी पी क्यू कर लेते हैं। कैसे इसको विजुलाइज करते हैं? बहुत आसान है। स्क्वायर प्लेनर कॉम्प्लेक्स में किसी एक को एक कॉर्नर पे फिक्स कर दिया हमने ए, तो उसके डायगोनल पोजीशंस पे कितने डिफरेंट अरेंजमेंट हो सकते हैं? तो ए के डायगोनल में बी हो सकता है, पी हो सकता है, क्यू हो सकता है। अगर बी यहां पे लोगे तो इधर पी क्यू हो जाएगा, पी क्यू या क्यू पी एक ही बात है। अगर पी यहां पे लोगे तो इधर बी क्यू या क्यू भी हो जाएगा, बात एक ही होगा। और अगर क्यू यहां पे लेंगे तो बी पी, सो टोटल 3 मैं बना दे रहा हूं, ए बी पी क्यू, ए पी बी क्यू, ए क्यू बीपी। तो ए के रिस्पेक्ट में एक बार बी को, एक बार पी को, एक बार क्यू को हमने ट्रांस रख दिया, तो टोटल 3 आइसोमर्स और आंसर इसके 1 हो जाएंगे, 3 आइसोमर्स। क्वेश्चन नंबर 13। क्वेश्चन नंबर 13 is also a very straightforward question which we study in the beginning of chemical kinetics only. In question number 13, it is asked that higher order reactions are rare. Higher order reactions लिखा है कि greater than 3 रेयर होता है। That is true। क्यों रेयर होता है? क्योंकि 3 के लिए सपोज करो, इफ वी टेक द ऑर्डर 3, फॉर ऑर्डर 3 at a point 3 particles will have to collide simultaneously. अब 3 पार्टिकल साइमल्टेनियसली अप्रोच करे पॉइंट को सेम टाइम पे, इसी की प्रोबेबिलिटी कम है। और 3 से ज्यादा यानी कि 4 पार्टिकल इकट्ठा एक ही पॉइंट पे आके कोलाइड कर जाए, that will have further less probability, and so that will be less likely. So higher order reactions are rare due to decreased probability of collision of more molecules together at a point. Question number 14 भी यहीं पे कर लेते हैं. That is also very simple, straightforward. Question number 14 मैं पूछ रहा which is most reactive और options है Br2, I2, ICl and Cl2. This is again a very substandard question, I can say. Which is most reactive? Most reactive, least reactive, most stable, they are all relative terms. One can be most reactive in one reaction, least reactive in other reactions. So if nothing is given, then we'll take the general reactivity which depends for the covalent compounds on polarity, and it will be a polar, all other are non-polar. So on that basis we will say that the polar one will be most reactive. So next is question number 15, that is from electrochemistry, Faraday's law of electrolysis. So let us see the question number 15. Question number 15. This question is from Faraday's law, 2 Faraday. Question is 2 Faraday of electricity passed through CuSO4 solution. The mass of copper deposited at cathode. So 2 Faraday will give 2 equivalent of Cu2 plus. 2 equivalent of this. And we all know that number of equivalent is always equal to number of moles multiplied by n factor. So number of moles of copper deposited will be number of equivalent to divided by n factor 2, so 1 mole. And 1 mole of copper is what? 63.5 gram copper. So answer 1 is the correct one. So this is the first part in which we solved 15 questions. 15 questions of set B JEE Mains 2015. In the second part, we will be taking the remaining 15 questions, and in that part we have some also we also have some more good questions, like questions on intermolecular interaction, that is also very good questions, and some other numerical questions are also pretty good. So we'll be taking the remaining 15 questions in the second part.